This is November 2022 and paper is 51. And we have to do question number 3. Potassium bromate 5 reacts with potassium bromide and sulfuric acid to form potassium sulfate, bromine, and water according to the following equation. KBrO3 plus 5 KBr plus H2SO4 gives you K2SO4 plus 3Br2 plus H2O. A student is investigating how the rate of this reaction is affected by changing the concentration of the reactants in turn. How the rate of this reaction. So he's talking about rate of reaction. Is affected by changing the concentration of the reactants in turn. This is done by keeping the total volume of mixture constant and adding different small volumes of each reagent. The reaction produces bromine, which is orange in color. The student times the reaction and then determines the rate as 1 upon time. The rate equation for the reaction is of the form. This is the rate equation. K is the rate constant for the reaction. X, Y, Z are the respective order of the reaction for each reagent. The student carried out the experiment and obtained the following data. Suggest how the student might time the reaction and judge the end point of the reaction for each mixture.
He can use the stopwatch to time the reaction.
And judge the end point. End point should be, is there any color change in this reaction?
Yeah, bromine is being produced.
So he says bromine is orange.
Yeah.
So if it is bromine, then we can mention examiner that about the color change. Use a stop clock. How we manage the end point?
By the color change of the solution.
Maybe. Achha. The reaction produces bromine, which is orange in color. So maybe the production of orange bromine serve as an endpoint symbol.
Yes.
What should we time? That should we time till the endpoint.
Yes.
By comparing the data for the mixture, deduce the values of X, Y, and Z. So in the first thing, when 0.125 is constant, we can compare KBRO3 and H2SO4. The rule of one variable constant, so other can be compared.
Yes.
Look, when it is constant, we can see that KBRO 3.025 0.025 to 0.05, and it becomes 0.075 is also constant. So what is changing then?
KBRO3 is changing.
Hmm?
KBRO3.
But alone KBRO3 is changing. So we can take 0.075, the two are constants. So if we double the concentration, the rate, does it double or is more than that? The rate, if we double the 0.025 becomes 0.05, the concentration doubles, so the rate doubles.
No, it remains the same.
Remains the same. Why? It's 0.059 becoming 0.117.
Yeah. So the ratio is 2:2.
Hmm?
The ratio for the rate of reaction and the KBR3 is 2:2.
2:2. Have you divided it?
Yeah.
0.117 upon 0.059. Is it equal to 2 or approximately equal to 2?
Yeah, approximately. It's 1.98.
Okay. So it means with respect to KBRO3, is it first order?
Yeah.
Now, how we locate now any other 0.125, 0.125?
We can take A and C.
Here we have taken, for this one, I have taken AB.
Mm.
Okay, now what you suggest for what other, for KBR or for any other?
For KBR, we can take A and C.
A and C. Then KBRO3 is constant. Okay. So is it going double? KBR is doubling, and what about the rate is not changing, nearly the same.
Yeah. They're both 2:2.
Actually, you're saying A and C.
Yeah.
Acha, if we take A and C, okay, when you consider A and C, KBR is 0.125, so 0.250. So it's the rate is double. So what about 0.059 upon 0.118?
It will also be 2.
Double.
Yeah.
Acha. So 0.118 upon 0.059. Sure. What about now? What about now? Z.
We
We
can
can.
take
Hmm.
A and D.
Point 0.025, 0.125, then it is 0.059 से 0.235, A and D. So 0.235, how much is 0.235 upon 0.059?
It's 4.
So can we say the order is 2?
Yeah, second order.
The student carried out each reaction using a boiling tube capacity 550 cm cube and varied the concentration by adding different volumes of each reagent. For example, in mixture A, 5 cm cube of KVRO3 is required. Name a suitable piece of apparatus which used to measure this volume. 5 cm cube.
We can use burette.
We can use burette 5. Okay. Suggest why the reagents are heated to the same temperature before mixing. Suggest why the reagents are heated to the same temperature before mixing. So is he maintaining the temperature as a constant variable?
Yeah,
Because temperature is also a major factor which affect the rate.
yeah.
Temperature affects rate of reaction. It has to be same. The solution of sulfuric acid used in each mixture was of concentration this. The acid was prepared from a solution of concentration 1. Briefly describe how to make the more dilute solution, stating the capacity of any apparatus used. Briefly describe how to make the more dilute solution. So D part.
We can use the volumetric flask to dilute it.
We can use because this is a dilution method. So we can measure a volume, any volume starting and then, but what should be our starting value? Has he given us any starting value?
For the volume?
But what value we should take? Should we take any particular value, or he has not given us any starting value for this process? So used in each mixture was of concentration 0.15. Acid was prepared. Acha, original concentration is 1. So we are starting from 0.15, which is available, which we need actually. Acha, it means we have to convert H2 SO4. We need a sample from 1 mole per dm cube to 0.150. So we want to convert this. So you said use a volumetric flask. That's fine. To use a volumetric flask, should I take a measured volume?
Yeah.
Now look this. Now, after that, what should I do?
We have to reduce the concentration.
That is fine, but how we get it to 0.15? Our target is 0.15. So this is my point. I have the solution now. Should I fill the flask till the level?
But
By this,
shouldn't we add a measured amount of?
no. I have transferred the 1 mole per dm cube, but should I fill it till the mark?
Yeah.
It. Now my last question is the same. How can I draw and get 0.15? 0.15 is the concentration. Concentration is equal to number of mole upon volume. So what should be the last step? We have done till here, and we need to mark. Now we have our diluted solution is ready. But in this, normally it is 250 cm cube. It is diluted till 250 cm cube. And how we get now, how we sample a derivative, a multiple of 0.15.
We should divide the 0.15 by the volume.
Acha, okay. The sample volume which we need, we should put it there. And when you dilute something, do you change the number of moles?
Yeah.
No. How dilution can change the number of moles? Dilution can actually change the concentration, but dilution cannot change the number of moles. So number of moles are the same. So we can put you're right that we know the sample volume, we know the concentrate, we know the moles, so we can find the concentration to be logged at 0.15. So we can this idea C1V1 is equal to C2V2. So
Yeah.
we can C1V1 is equal to C2V2.
V2 will be 250 centimeter cubed.
Hmm. So this is the point.